Okay, today's video is 5.2, Factoring Quadratic Expressions. Today's goal will be to convert a quadratic in standard form to factored form. Our key term today is quadratic, and a quadratic is a special type of polynomial that includes a term to the second power, and that second power being the highest power that's in the expression. So we've got our quadratics in standard form, where you can see that the highest power is the second power, and then they've ranked them from highest to lowest, all the way down to the constant. And then on this right side, we've got a quadratic expression in factored form, where if you multiplied this factor right here, x plus r1, to the factor x plus r2, they would multiply to give you the standard form of the quadratic expression using the box method. So what we're doing today is we're going to convert from standard form to factored form. So it's important to understand what some of these variables, how they're related to each other. So c in standard form is equal to the two factors r1 and r2. If you multiply them together, they should multiply to give us c. And then b, the coefficient in front of this x term in standard form, when you add those two factors r1 and r2, they should add up to b. So we're going to use this information to convert from standard to factored. Let's go ahead and get into example number 1. So the example is asking us to write in factored form, and you can see here we've got a quadratic in standard form. So our first step will be to identify c and b. So we know that c is 6, and we know that b is 5. We've got b right here, we've got c. And what we're going to do is we're going to list the factors of c. So we're going to list the combinations that multiply to give us 6. So 6 times 1. 1 times 6 is the same thing, so we don't need to rewrite it. We've got 2 times 3. And then obviously 3 times 2, we don't need to rewrite that. These are the two combinations, but there's two more. There's negative 6 times a negative 1, and a negative 2 times a negative 3. So now that we've listed all the factors that multiply to give us this 6, we're trying to figure out which ones add up to 5 when we add them together. So negative 2 plus negative 3, that would add up to a negative 5. That's not b. Negative 6 plus a negative 1, that adds up to negative 7. That's not 5. 2 plus 3 is 5. So we've identified the factors that multiply to give us 6 and add to give us 5. So we know that we can now write our factored expression, where x plus 2 times x plus 3. I could write x plus 3 times x plus 2, as long as you've got them both in parentheses being added to the x, because they're both positive. If we wanted to check our answer to see if we found the correct factors, we could just set up the box. So x plus 2, x plus 3, and then we multiply our box out, and we would get x times x is x squared, x times 2 is 2x, x times 3 is 3x, and 3 times 2 is 6. These are like terms, we would add them up. X squared, and those add up to 5x and plus 6. So you can see that when we multiply them, we get the original quadratic expression. Example number 2. So in this example, we've got x squared plus x minus 12. C equals a negative 12. And b equals, you don't see a coefficient in front of x, so you know that b equals 1. So combinations that give us a negative 12 when we multiply, negative 12 times 1, and 12 times a negative 1. Then we've got 3 times negative 4, and negative 3 times 4. Then our last combination would be 6 times negative 2 and negative 6 times 2. So you can see that it's kind of important to write combinations with the opposite negatives, because we need ones that add up to positive 1. So let's go ahead and add these up. Negative 6 plus 2 is a negative 4. That's not the right factor. Negative 2 plus 6 is a positive 4. That's not correct. Negative 3 plus 4 is 1. So we know that these are the factors that give us negative 12 when we multiply, and when we add, give us a positive 1. We can go ahead and write the quadratic out in factored forms. We've got x, and since it's a negative 3, we're going to write minus 3, and x plus 4. If we set up the box, we would get x squared plus 1x minus 12, because we know that they add to a positive 1, and they multiply to a negative 12. Example number 3. So we've got x squared minus 9x plus 8, where 8 equals c, and negative 9 equals b. Combinations that give us a positive 8, 8 times 1. We don't need to write 1 times 8 because they're both positive numbers. It's not going to change the addition. And 2 times 4. And those are the two combinations. But there's two more. There's negative 8 times a negative 1. That would give us a positive 8. And then there's a negative 2 times a negative 4. So this is kind of important sometimes to make sure that you include the negative ones. So let's go ahead and add them up and see what we get. So if we add these up, we would get 9. If we add these up, and 9 is very close to a negative 9, so I'm going to go ahead and skip this because I know it adds to 6. I know this adds to negative 6. So negative 8 plus a negative 1 is a negative 9, and that is the coefficient b. So we know our factors are negative 8 and negative 1, so we can go ahead and write in factored form x minus 8, x minus 1. And this would be our final answer here. Example number 4. It says, write in factored form x squared minus 9. So I know that you're already thinking, how come there's only 2 terms? We've only seen examples with 3 terms. And so this is a special case of quadratic. It's called difference of squares. And it's going to be important to understand this special case. So let's go ahead and figure out what c is. So we know that c equals negative 9, and we do not have a b term. There's no bx term. So we can go ahead and say, since there's not a term, b equals 0. So the factors that give us negative 9 when we multiply, negative 9 times 1, then the opposite, and 3 times a negative 3, and these are the 3 factors that give us negative 9 when we multiply. So which of these adds up to 0? Well, negative 9 plus 1 is a negative 8. That does not add up to 0. 9 plus a negative 1 is a positive 8. That does not add up to 0. And then 3 plus negative 3, these are opposite numbers, so when you add them, they add up to 0. So these are our factors right here. And that's why they're called difference of squares. When you have a number that has a square root of a whole number, you take the square root of 9, those factors of 9 that are the same number but opposite signs will be the factors r1 and r2. So we've got x plus 3 times x minus 3. And this will be our final answer. So for example, if we had something like x squared minus 144, I know that the square root of 144 is 12. So I know that my factors are going to be x plus 12 and x minus 12. So it's a quick way of identifying what your factors are. If you see there's no b term and then the constant term has a perfect square root, then you know your factors are those two numbers, one positive, one negative. Alright, last example today. So here we have our last example, and this is also an example that you're going to want to keep note of. The last example was the difference of perfect squares. This example is the sum of perfect squares. So our C here is 81, and our B equals a negative 18. Factors that multiply to give us a positive 81 are 9 times 9, negative 9 times a negative 9, and let's go with those for now. There's obviously 18 times I'm not sure 18 times 4.5, but these are good for now. So 9 plus 9 equals 18, and negative 9 plus a negative 9 equals a negative 18. So you can see here that our factors are negative 9 and negative 9. That's the sum of perfect squares. When you add the factors together, they should add up to B, and then when you multiply them, they should multiply to C, and they're the exact same number. So our expression here is x minus 9 and x minus 9, where we have the same exact factor. We can also write this as x minus 9, and since it's being multiplied to itself 2 times, you can just say x minus 9 squared. That's what the sum of perfect squares is. Good luck on your homework.